In this problem, we're asked to find the equation for the voltage on the capacitor as a function of time. We're given a 10-volt power supply, a switch that closes at time 0, 2 resistors, and a 10 microfarad capacitor. This particular problem is complicated by this resistor right here. As we start, it's useful to review our note cards. Here we have RC transients when we're dealing with an initially uncharged capacitor. And we are told that as a function of time, the capacitor voltage changes. It changes via this curve right here, eventually reaching the source voltage. This gets complicated because these two resistors form a voltage divider. So Vs, the source voltage in this case, is not 10 volts DC. It's something else. To see what it can be, let's review Thevenin's theorem and how to apply it. The first step for this problem is to temporarily move the capacitor. We're going to replace that with our stick figure looking into the circuit. The next step is to calculate the Thevenin resistance, and we do that by short-circuiting the power supply. Okay, so we take this 10 volts and we assume that's a short circuit. And for this problem, we'll also assume that the switch is closed. When we do that, we'll see that we have 2 resistors in parallel. The next step is to turn the power supply back on and calculate the open circuit voltage. And when we're done, we can substitute this for the rest of the circuit, where we have a Thevenin voltage and a Thevenin resistance. One last thing from our note cards. Let's review the concept of a voltage divider. Here we have a source, we have 2 resistors, and we can calculate the voltage on resistor R1, which is the upper one here, as R1 over R1 plus R2 multiplied by the source voltage. Or we could calculate the voltage on the lower resistor by saying the voltage on R2 is R2 over R1 plus R2 multiplied by the source voltage. Back to the steps for Thevenin. We've temporarily removed the capacitor. What we're going to do now is we're going to short the 10-volt power supply and have this switch closed. So we're going to have a 1K in parallel with a 2K. So R Thevenin is equal to 1K in parallel with 2K. And that is equal to 2/3 K ohm. Next, we want to do step 3, which is calculate the Thevenin voltage as an open circuit. And to do that, we use our voltage divider equation. And we say that the voltage, or the Thevenin voltage, is equal to R2, which in this case is the 2K, over R1 plus R2, so 1 plus 2. It's not necessary to use K in this particular case, as it'll divide out. And you multiply that by 10 volts, leaving us with 20 over 3 volts DC. Which brings us to step 4. We reinstall the capacitor and we substitute in our Thevenin circuit, where this R Thevenin is 2/3 K ohm and our Thevenin voltage is 20/3 volts DC. Now we can go back to our RC circuit, and we know this Vs, that's 20 over 3 volts DC, and we can calculate tau as RC. So tau is equal to RC. In this case, it's 2/3 K multiplied by the capacitor, which is 10 microfarads. We key that into the calculator as 2,000 divided by 3 multiplied by 10 raised to the negative 6th power, which gives us a tau of 6.6 milliseconds. And we can now write our complete equation. So Vc of t is equal to 20 over 3 multiplied by 1 minus e to the negative t over 6.6 milliseconds. of how do you fix that?